So our afternoon panel is the Mitigation Toolbox. And what I would like to do is our panel moderator and organizer is Heidi Gill. She's with Anadarko Petroleum Company, and she's the Senior Mitigations Representative. And with that, I'll leave it with Heidi to introduce the rest of the panelists and to walk you through the Mitigation Toolbox ideas they have.
Perfect. Thanks, Kirby. Can everybody hear okay? If anyone has issues or can't hear us when these guys go to talk, we have 4 different microphones, so let us know. So I'm Heidi. Like Kirby said, I'm with Anadarko. Really excited to be here to talk about this today. I personally am very passionate about urban mitigation. It's something that we, as everyone in this room knows, affects so many individuals, communities, families, and it's something that I know a lot of you have kind of on the forefront of your discussions with a lot of the people inside your communities. The way that we do want to do this panel is we have some content prepared, but primarily we really want it to be a discussion. So if at any point you guys have questions about the specific mitigations that we're looking at or anything like that, please just raise your hand. We want to make sure that this is very beneficial for everyone. Please ask questions if we're getting too technical and potentially not explaining all of the mitigations properly. So just let us know, and we want to have that open dialogue with you guys. So to introduce the panel, to my left is Jacobsen. He is the Senior Vice President of Extraction Oil and Gas. Then you have Mike Eberhard, who is with SRC Energy and is the Chief Operating Officer. And then Ben Poppel, who is the Engineering Manager at Liberty Oilfield Services. So that's your guys' panel for the day. So before we kick off, I just want to go over a couple things to make sure that everyone in the room is on the same page with kind of the content that we're discussing and what we're hoping to show everyone today. So like Kirby said, we're really here to talk about nuisance mitigation. So when we talk about how we might potentially utilize additional odor mitigation at a location, we want to make sure that everyone knows that whether we use that mitigation on a location or not, all of our operations are within full compliance of the state regulations. However, even when you have a fully compliant operation, you in this room know, just like we do, you can still have nuisances with that and have people that potentially are not happy with that operation. So we want to make sure that when we talk about how these, and showcase these tools and techniques, they're not all for every single location, but just know that compliance and nuisance are two very different things, and we are committed to the health and safety and welfare of all the stakeholders near our locations, our employees. Compliance is the baseline, but for today's panel, we're really here to talk about the nuisance space. And so what are the tools and techniques that are available to mitigate nuisance? And that's really what we're here to discuss today. And then lastly, what we're trying to do is kind of get through and showcase different types of tools and techniques that can be utilized. It's not where you use all of these at every single location. Just like I'm sure you hear industry talk about quite often, not every location is the same, and not all of these tools are applicable at every location. So it really is industry. We really support site-by-site evaluation to determine what the most effective mitigation is. So again, we're just going to kind of roll out the toolbox and go into discussion about how these potentially can be used, some in conjunction, some standalone, and then sometimes they're just not applicable at certain locations. So with that, we'll go ahead and get started. So one question that I think that, or even just to kind of set more baselines and framework for the discussion is, oil and gas now is very different than it was 5, 10, 15 years ago. Especially in the last few years, it's changed substantially in terms of best management practice, mitigation techniques. So my question to you guys is, you've all been in the industry for quite some time. What's that BMP evolution look like? How did we get to where we are now?
Mm-hmm. I can take a shot. Thanks Heidi. Thanks for inviting us here. And for all of you for attending. So I'm speaking on behalf of the DJ Basin primarily, and the unconventional revolution that's happened there in terms of developing the Niobrara and the Codell. 6 or 7 years ago, I would categorize it as a tanks, trucks, and tongs basin. And don't get me wrong, tanks, trucks, and tongs still work in a lot of places. But over the last 6 years, we've seen rules change from the COGCC. We've seen, as per Mr. Matthews, the legal actions change. The size and scale of the development has been remarkable. Mr. Akers showed a plot earlier on the ramp in Colorado production, primarily driven by the DJ and Weld County, almost exclusively. So, and the attention by communities and the emotional level, the sensitivity to nuisance, the eyes on compliance, all of that has changed dramatically in the last 6 years. And oh, by the way, price dropped by 2/3. So with that suite of changes, it's demanded industry to come to the table with a higher level of best management practices, a different degree of efficiency, of innovation, of technology. And how it's happened is all of those things in combination have demanded that we do things differently and better, and we have done. And as Heidi said, there's a kind of a toolkit out there of best management practices. It's not a one-size-fits-all. It's a fit-for-purpose application, and it includes things like different, if we start downhole, different casing and cementing designs. Dr. Fleckenstein had a great presentation, and most operators in the basin now are in that category 6 or 7 in terms of our casing design. We're better about understanding how to protect vertical wells and what that means. Matt Lepore talked about the 1,500-foot distance on vertical well reclamation and protection. On the surface, sound walls. Ben Poppel will talk a lot about the quiet fleet that Liberty Oilfield Services has innovated. Amazing technology. We've gone to electric drilling rigs in places. We've gone to, it's kind of an offshore technique, or North Slope of Alaska, where we go to consolidated facilities and you can get rid of tanks and lots of equipment on an individual small checkerboarded basis and consolidate it into one larger facility where you can afford to have very, very high-end vapor recovery and tank management and process safety management, which is really, really key to us. We've advanced even our BOPs in the basin here and our well control technology. So all of these things have come about over the last 5 or 6 years with all the things I mentioned, the size and the scale, the incredible development pace, the regulations, the legal scrutiny, the public scrutiny, the drop in price. All of that has commanded us to do things differently and better, and I think the industry has rose to the occasion in a lot of ways. I wouldn't say we're there yet, and we'll never stop innovating and looking for better. But when we go into each community or each location, we assess the need of this toolkit of best management practices. Sometimes almost none of it's required, and we go with compliance. And as Heidi said, compliance in and of itself is a major feat. People who are in the industry know that compliance in and of itself is difficult to achieve. I think we counted up, we have 5 federal agencies, 4 state agencies, and 5 standards and practices organizations that we are governed by, or that we adhere to every time we drill a well. So 14 agencies or standards and practices. So compliance in and of itself is difficult. All these best management practices tend to be, in many cases, above and beyond compliance to address the nuisance aspects or what the communities or stakeholders need. So I'm really proud of how far industry's come, and the panel up here, among many of you in the room and all of our industry peers and colleagues, have come a long ways. We have far to go yet, and I know that we're the type of industry that never stops innovating, never stops competing, never stops looking for efficiencies, but it has come a long way, and I think that Mike and Ben can talk even more about some of the fantastic things they've done in their careers and companies.
You didn't leave much. First off, I'd like to thank Heidi for just saying 10, 15 years in the business. Some of us have been around a lot longer than that. So, but as you know, having been in the business for, 36 years now, I guess, we talk about the recent changes. My entire career has been innovation inside the oil and gas industry. What we did, even when I was back in the day, is nothing like what we do today. And I think a big part of that is the people in this industry always want to do what's right. They continue to look for better ways to do things, more efficient ways to do things, ways to make wells produce better, and also ways to minimize our impact. There has been a lot more awareness. We have an overprint of urban development going on in the Weld County, Adams County, Broomfield County, that's really brought a level of awareness to what we do. But I think there's always been an underlying drive within the industry to get there. It's just been a lot more public now, and it's in a lot more open forum and discussed a lot more. So I'm really proud of the business that we've been in. And I think, as Eric said, we've gone through, there are a lot of best management practices out there. Just compliance in itself is nothing like it was in the past. The COGCC, the rules making that's been in effect has really driven a lot of innovation in itself. But we continue to look, we continue to strive, and I think to me it's just the awareness, the innovation, and the things that we can do, the reducing the amount of time we're on a location, or other mitigations that you really don't even get credit for. We can drill a well in 5 days. It used to take us 25 days. So if you were to go do some of these pads, we'd be out there for 2 or 3 years. And we're getting it down into much more manageable time. So, you know, we're very conscious of what's going on and look for ways to even further reduce a lot of that stuff and going above and beyond. If you know, one example I have is a recent pad we completed. We were using a road that was approved road by the county, and this was the route they wanted us to go, and we were doing that. But at night, the truck would rattle down the road and keeping a gentleman awake that lived just off the road, and he complained a couple times. So we rerouted the trucks. It only added 2.5 miles to one way on the truck traffic, but when I did the math, that was over 10,000 miles of additional mileage we drove to avoid this gentleman's house. So mitigation, best management practice, doing what's right, listening to you listened to Jim Kent earlier, listening to what the stakeholders have to say, trying to do what we can within best reason. I think those are all the things that we're striving for, and as everybody's saying, one size doesn't fit all, but we have ears, we live in the communities, and we're trying to do what we can to be a good part of that. And I just think a lot of it's the awareness. This stuff's always been going on, but we're just much more aware now.
You did pretty good for me not leaving you much.
Some of the biggest changes I've seen in the past 10 years in the DJ have been moving from vertical wells that were scattered all over the county to consolidated multi-well horizontal pads. Having been out there fracking these jobs on vertical wells, it used to be a Monday through Friday type of job. You'd show up early in the morning, you'd be gone by night, and we were done. So I think the impact was lower to some degree, but more common. Now we're seeing it in a single location for a longer period of time. However, we're much more efficient at extracting those resources. So there's that balance there. Some of the challenges that were there before aren't there anymore, and vice versa. You know, and there's lots of things we've done mechanically, and then with systems, with other forms of sound mitigation, light mitigation that we're going to get into later on, that we didn't have years ago. I think another thing that's really interesting to me is seeing, you know, now we're putting up these sound walls, which I know we'll show later on, but the public perception of that sometimes is, well, now they're trying to hide from us what they're doing behind there. That gets really difficult because that's not why those walls are there. That's some of the biggest things I've seen is really just the change in format from Monday through Friday, 4 a.m. to just after lunch, and to a 24/7 type of operation. So we have to deal with those challenges.
So I think you guys brought up a lot of good points, and we'll kind of elaborate on some of these as we continue with other discussions. But one thing that I think is also important to point out is that, and I think I speak for any operator, we don't want to have to put these locations next to a community. That is by no means our goal. And so, you know, living in the state that we live in, you do have competing land use, and we have more and more people that are moving here every month. And, you know, it's a challenge. Urban mitigation, urban operations are not going to be going anywhere. So I think that it's important to understand that when these locations get to where they're at, that company has probably tried everything possible to not be 1,000 feet from the school or 500 feet near someone's home. And there's so many limiting factors to why that has to be there through regulation, geologic considerations, what minerals you have, what leases you're able to get, what the surface owner would like. One thing we'll talk about a little bit later is you often have competing you have competing interests between what a surface owner wants and then what maybe a regulation or a local government would want. And that's something that we have to work in good faith with the surface owner and try to accommodate what they want on their property. Sometimes they do not want sound walls. Sometimes there's a specific type of fence or landscaping that a local government might require. And if the surface owner doesn't want that, it's how do we work to balance these? So I think that the first thing to realize is that the #1 mitigation we're always going to try to utilize is sheer proximity. We don't want to have to put it there. But if we do, like Eric and Mike were saying, we want to always continually innovate and have discussions with all of you and communities and really strive towards that social compatibility. So always know that we're trying to get it as far away as possible. So with that, maybe we'll just go ahead and transition a bit into drilling. So just like we're saying, by the site-by-site specific approach, it's the exact same with drilling. You have different number of wells. You need to have different reaches for those wells. So there's a slew of different types of drilling rigs that you can get to come in and do that work. And those rigs are picked specifically to come in and based on the capabilities of that rig for what those wells need. What are some of the tools that have been utilized to mitigate all those types of rigs, everything from whether it's a workover all the way through a production rig?
You want me to have a go? Okay. Yeah. So yeah, the drilling is just, I'm glad you went into that. It's just one facet of all of the different best management practices as well as technology advancements. So on the drilling side, to your point, Heidi, about locating as far away as you can from a municipality that happened to build on top of rich organic deposition from the Cretaceous Seaway, and we have leasehold on, we try and locate as far as we can away from those areas, no doubt about that. In fact, in one particular area we're entering now or about to enter, we'll be drilling, we'll be stepping out a mile as we build depth and get the build the curve, and then we'll be drilling 2.5 miles laterally. So that sort of technology, I wouldn't say, Mike, 6 years ago we could have done that. No way could any of us drill, stepped out a mile and drilled 2.5 laterally, and then go frack the well. So we're doing that. I know SRC and others are in that camp. So just that technology advancement itself. Not to mention the electric rigs in a lot of the locations we go where there's high line power available and it's feasible and reasonable. We will use high line power rather than diesel or LNG driven electric generation. So we've gone to closed loop systems almost exclusively everywhere. There's no such thing as mud pits anymore. We're we have incinerators on the rig to burn any of the gas coming off the mud. All sorts of things. Mike, help me out here. Workover rigs, I'll say, we've really upped the game on our BOP management and our BOP compliance there, with a much higher degree of rigor, at least I'm speaking for extraction, than has ever been before. We're actually adding some shear rams to our BOP stack on our new drilling rigs. So just an enormous number of safety, best management practice, and technological advancements on that's just the drilling side alone. Mike, you have probably forgot a handful. Mm-hmm.
Yeah, I think one of the things that is important to keep in mind also is that drilling rig, there's limits to how far away you can get from where you need to be with a drilling rig. Frac crews and some of the other things that go on, you can get a little bit more remote, and Anadarko and other companies have done that with remote stimulation centers, and that works out pretty well. But a drilling rig pretty much has to be where you want to drill. And some of the things that go on, as Eric said, there's electric rigs, but if you even look at the diesel electrics that are out there today, the technology that's involved, one of the big noise sources on a drilling rig, and we've done surveys on the rigs. You go out and you can do point source sound surveys and determine where all the sources are coming from, and you can model that. And shell shakers used to be is one of the largest areas. Well, we've come up with a new shell shaker design. In the past, people didn't worry about it a lot, and you're trying to start, this is a source, what can we do different? We went to a vertical shell shaker. Completely changed the game on that. And it's just that innovation that came along with once you understand where the problem is, let's go look at it. Doesn't mean we can always solve it, but we can sure take a look at it. So shell shakers are an example, enclosing the generators, putting rubber grommets on the drill pipe so it doesn't clang as much, even as simple as just the way we have our lights set up on the drilling rigs. So they're not broadcasting wide. They're more focused and going with LED lighting and things like that. Those are all things that are being done, and it's an evolutionary process. But you know, I think, and also to Eric's point about being able to step out and drill a 2.5 mile lateral, that is technology that had been available, but it was offshore on rigs that cost $200,000, $300,000 a day, $400,000 a day. That technology was available for them, and they got the price for it. As we stated earlier, prices have dropped. That service is now, there's a lot of them tools that are sitting out there that we were able to bring on land and use those on land, where before we just couldn't afford it. It was absolutely, you just couldn't afford it. Well, now we can get them on here, and that's what's allowing us to do this and step out and drill underneath the city of Greeley from the north, south, east, and west. I mean, everything, that's rock that hadn't been touched since the beginning of the DJ Basin, and we're getting to it now with that technology. So there's a lot of things going on just on the rigs themselves, on the workovers. You know, again, working with just the lights on a workover, how we put the lights, making sure they are safe. I want to stress safety is #1 in every operator's world. We want the community to be safe. We want our people to be safe. We want everybody to go and come from that location, and anybody that's around there to feel and know that it's safe. That's our #1 goal. So we'll talk a little bit about frac crews and coil tubing drill outs and a lot of that stuff that goes on too. We're all focusing on how do we mitigate a lot of this, the nuisance aspect of this thing.
Before Ben goes, I had one thing that struck me, and you'd raised this earlier, Mike, in terms of drilling. Actually, in effect, the drilling efficiencies we've been able to gain are a best management practice from the community's perspective, I would think. Because what used to take us 10 to 12 days to drill now takes us 4 to 5 days. Most companies are doing these 2 mile laterals, spud to rig release in 5 days. And that allows us to get in, be safe, and get out very quickly with the least amount of impact to the communities. So it's good for the operators, it's good for the communities, and the technology that's enabled the efficiencies and the reduction in commodity price that's driven us to higher technology, higher efficiencies, better innovations, in a way is a best management practice, because it's good for all seasons and good for all members.
Can't comment too much on the drilling side, other than longer laterals are meaning more stages. More stages mean I'm pumping more. Good for us, but also comes with other challenges of materials and how we handle that. So we'll touch on that later on, I'm sure. But what's been interesting to me to see is that a lot of the things that are actually there to help us with efficiencies, or actually there for mitigation purposes, are actually helping us with efficiencies. I know, actually, I think on a well of yours, we just did I think 9.3 million pounds in one day, pumped down one well bore, or excuse me, down several well bores in a 24-hour period. Not something that would have been accomplished with old style systems.
So to give everyone an idea, so this is an example of, so real quickly, when they're talking about shale shakers, for anyone that doesn't know, it's just basically you generally have about 3 of them on a production rig, and it's just, think of it as separating fluids from the drill cuttings. So these boxes here, so this is a not enclosed shale shaker here, and you can see, let me get the little pointer. Oh, I just shouldn't touch it. I can't find the pointer. If you look right there, you see that those are not enclosed, and that's how they used to be historically. So working, like Mike was saying, you can go to specific rigs, utilize source-specific mitigation. And when we say source-specific, it basically means that the closer that you can get the mitigation to whatever is emitting that noise, that really is where you'll get the most sound attenuation. And so by working with acoustic vendors, we've figured out ways to mitigate different parts of all these separate drilling rigs. So, and actually, if you look on the right-hand side, those panels, that's actually a different form of mitigation, where they're hanging acoustic material panels around the shakers. So these two look differently, but they both have mitigation techniques actually on the rig. And those are exactly the same thing with the shale shakers that are just have steel enclosures, and on inside of those steel enclosures are acoustic absorbing materials. And then they have, you know, different tools there to be able to lift those up to still access the shale shakers. So with that right now, does anyone have any questions so far?
I can yell too, it's fine. I just thought it would be a good idea. Dan Carter from COGA. I get a lot of questions from local governments about why can't everyone use electric rigs. So could you talk a little bit more about the limitations of those and why they aren't standard practice?
Yeah, absolutely.
From our perspective, you know, really, the economics eventually comes into play with everything, and sometimes high line power with sufficient voltage and amperage is readily available at a reasonable cost, and sometimes it isn't. And what we find is usually in the urban areas, the real urban areas, it's oftentimes readily available and we can use it, but in the more rural settings, oftentimes it's not. So it does often come down to, you know, sometimes the rig, I guess the rig has to be fitted for it, which is reasonably available, but you know, economics does play a role. And I think the other thing is scale matters. If we're drilling 100 and some wells in an area, usually you can afford to bring in some electric power to serve it to suit an electric rig. If you're drilling 5 or 6 wells, oftentimes those economics just don't work. So you have to come with other mitigations. It's not that electric power is the only solution. You've seen some other things. Mike talked about sound walls and the rubber grommets on the pipe and the enclosed shale shakers. So that's not the only thing as electric rigs, I would say. Sometimes it's feasible and economic and reasonable. Sometimes it's not. But I think what I would say, and to these local governments, is that's not the only silver bullet out here. There's plenty of other options to make these more compatible.
Yeah, I think when we think about an electric rig, you may think, okay, that's going to be quiet, right? Well, there's so many other noise sources out there that are not a function of an electric drawworks, a generator. We actually, if you go out to the Precision rig here, it's a diesel electric. The engines are all enclosed. And you go inside the engine house, it's loud as all get out in there, but you don't hear the engines. It's not the old days where they were sitting up on top of the floor and you could hear every time you came off bottom those guys rev up. You don't even hear the engines anymore. It's all the ancillary stuff that we are working on, like say the shale shakers, the vac systems, all the rest of the stuff that goes along with this that we're working on. But to just go with an electric rig and say that's my noise, I won't hear it, is not that straight. The other thing, and Eric talked about a little bit, there's pretty good load associated with these things. And if you put them at the end of a line, and we're coming off bottom with that mile step out and 2.5 mile, and they have pulling off with about 500,000 pounds of pull, things are going to get brown. So, I mean, that's just a tremendous draw. So, to gear up an entire the subsystem to handle that is not fundamental. It's a challenge, similar to electric frac crews and things like that we've talked about. You know, you end up putting your own generator source out there, which is a source of noise in itself. So it's just getting on the grid. Our grid is not that great, and these things take a lot of power.
I think a good thing to point out too is we'll kind of transition over to the completions or hydraulic fracturing, and we'll kick it to Ben to talk a little bit about Liberty's development of the quiet fleet. And I know I personally think, and you two could correct me, but what Liberty has done with their innovation for the quiet fleet is absolutely remarkable. And 2 years ago, you know, when I remember when Roy came and talked, and he's like, "We're going to have this." I was like, "That's funny." I was like, "Buy me a beer if that actually ever comes to fruition one day." And sure enough, you know, give oil and gas enough time, tell them the problem, and these mines are incredible. And to come up with what they've done for the quiet fleet has been a huge innovation. And Ben, I'll let you talk about that in a second, but Mike, you might be able to talk about what you were just saying. With the amount of electricity, you might think, oh, we can have an electric rig, then we want an electric fleet. It doesn't really work that way. So the amount of electricity that you need for a rig, like Mike said, is already a heavy, heavy, heavy load. You have to update infrastructure, and it can be very difficult to even do that for a drilling rig. For a frac fleet, it's virtually...
It's a lot.
How many times more? Not
Rifle's going dark.
Yeah.
I mean, for a frac, there's two things. Usually, a rig has kind of intermittent power. When it's drilling and dropping, it's not that big a deal, but coming off bottoms where it has to pull a lot of its horsepower, and its pumps take horsepower. Well, a drilling rig has about 3,000 horsepower on its pumps. On a frac crew, we have about 24,000 horsepower. And that horsepower is running all the time. So this is a big load. And I can't remember, we had an electric fleet that came in, and it was a 500 kilowatt. I can't remember what it was.
Just ball service.
Yeah, I can't remember what the load. They had a I love the name solar generator, but it doesn't run on solar. It runs on natural gas. That came in, and it's basically the size of 2 tractor trailers.
Solar turbines.
They're big turbines. Is exactly what they are. So, you know, you think, okay, we can do that, and we'll enclose the turbines in this, and we can get them away from everything. But that extension cord's about that big around, so you can't get it too far away to run that power. And again, talking a little bit about ancillary activities. Just the fans one of the largest noise sources on a frac truck is the fan. It's not the engine. These fans, we cool the transmissions, we cool the engines. There's 2 huge fans on these things, and Ben can tell you a little bit more about them, but these guys beat a lot of air, and that's a lot of what you hear. So, you know, we're looking at alternate cooling technologies, and I know Liberty has a cube that they're using, things like that. You know, I've challenged the industry to say, I pump a lot of water. Can I just run my water through these engines and keep them cool there? But I still have to get the transmissions cool. So there's still a cooling source there. But even with an electric fleet, you still have the fans on the pumps and the transmissions, because you still have a lot of heat source there, and you have to keep that cool. So it's not just you know, it's just not a simple thing. If they can make a vacuum cleaner quiet, it runs on electricity, right?
Yeah.
But there's a lot of noise there because of what it has to do and how you have to do it. That's why there's a lot of noise associated with this. There's just a lot of things going on.
Yeah, exactly. I think it goes back to the public perception of people think electricity is just this thing that comes from a wall. You charge your cell phone. That's not the type of electricity we're talking about here. We're talking about enough to power probably half the city of Greeley. Definitely probably all of Rifle. And in Greeley, there's brownouts when people turn their air conditioning systems on in the summer. Just not going to happen. Not in the near future, I don't see. Building the fleets was a multi-year process. We tried a couple different iterations, some with just the mastic patch sort of hanging acoustic barriers on the trucks. Didn't quite work. Built boxes around it. Actually made some of the noises worse, sort of acting to act as a speaker. So it's not that simple. And then there's some unintended consequences of it. We were afraid that things were going to be overheating at points. The trucks actually run colder now. We have better airflow across the engine that wasn't there before. We've actually installed fire suppression systems. I'm not sure if you guys have seen on the internet or other places of frac fleets burning down because of accidental, you know, hydraulic oil lines breaking, spraying on a turbine, or excuse me, an engine turbo, and burning down a fleet. Terrible, terrible for everybody involved, and a huge safety problem. With the fact that we're now enclosed, we can actually have a fire suppression system built into each unit that can be activated remotely and kill any fire that was happening on any of our units.
So real quickly, Ben, so just so everyone has an idea, so this is Liberty, this picture right here of their enclosed pump truck. And when they're talking about pump truck, he's really talking about just that shell that's on top of each individual truck that you guys see that kind of drives through the community when it's assembling. So to give you guys an idea, this is of a pre-modified conventional frac fleet, and you can see that those trucks aren't enclosed. And so this is the best picture Ben and I were able to find of a truck where that is not enclosed. So that's when he's saying that they enclose their pump trucks. That's what they're referencing.
I would like to clarify, fires on frac fleets don't happen very often.
Very
It's
true.
a very remote chance of that happening, but when it does happen, it can be
Yeah, it's a low probability but a high consequence event.
High consequence.
And that's why you put your fusible loops and your fire suppression system. There's always, Mike mentioned earlier, safety is #1 priority, and I think that's something that we have to look at each step of advancement on the technology side, because there can always be a pro and a con. If you enclose your shakers, you're actually potentially creating a hazardous atmosphere without ventilation. So you have to assort that with proper ventilation. When you enclose your pumps, you have to create enough ventilation and include fire suppression there because you can't see it routinely. So with every step of innovation comes some thinking around what are the unintended consequences, what are the what-if scenarios, and those are something behind the scenes the industry goes through on every step of the way. So a lot of this stuff might seem really neat and shiny and new when it comes out, and it's great, but there's a lot of thinking behind the what-if scenarios also.
And Ann, one more point to kind of your question about just the, being able to electrify, whether it's a rig or a fleet. The location that Mike's talking about, where we did have the electric fleet, I worked that project, and we still got calls from the neighbors. And we had to go and then mitigate the fans, and we had never had those large of fans, and you still had people in the community that weren't happy with it. And I think that that's something that, when you talk about, you have your compliance and you have your nuisance, and nuisance is such a moving target. Even in this room, I've met with several people in this room in local governments at different times where we've come up with, okay, our community really cares about this. And we're like, okay, and we come up with a resolution, and then we bring it to a different local government, and we're like, oh, here, we have this. And they're like, we don't care about that. Like, that's not what we want. And so, when you have these nuisance-based stuff, it's also very discretionary based on the individuals. So that's something that I know as industry we're really challenged with, that even if you do bring an electric fleet or an electric rig, sometimes that's not necessarily someone's concern, which, to Mike's point again, it's so important for us to be talking to the communities and getting out proactively, working with local governments and working with community leaders to figure out what those concerns are. I know that at Anadarko, we really do support a lot of pre-application meetings and then even just monthly meetings with local governments to be able to understand what the specific concerns were. And like I said, in this case, we had what we thought was the most technologically advanced frac out there, and it still didn't cut it because that wasn't that family's particular concern. So kind of moving along from that, I guess we can go ahead and, since we've looked at a little bit about the equipment stuff, we can look at what are some other types of source attenuation techniques that you can utilize. So hay bales, panels, source, when I say panels, I mean source panels, sound walls. So what would you guys say at either extraction or us just, I keep on calling synergy. Yeah, what would you guys say are some of your techniques that you like to utilize for these, and when they're applicable, when they're not?
I'll go first.
Yeah, thank you.
I'll leave you something to talk about. Heidi brought it up first time. Distance is our #1. If we can get everything away from people, we're going to do it. I mean, that's our #1 goal. Is distance cures a lot of problems. But after that, one of the things that we've done with a lot of the sourcing is we can model how we situate a drilling rig versus the topography around there, and which way we want to do it. Within reason, there's it's just not anything. You can't just do whatever you want. But we use upfront modeling to tell us which way we want to put the drilling rig, where we want to put the back, what we call the backyard, and things like that, so that we can direct noise that does exist away from people. So that's one of the things that we do. We do, as Heidi said, source mitigation. We'll put up internal sound walls. We'll put up external sound walls. One of the things that works pretty well is a berm, where you have the land to do that. One of the things we combat is we try and not disrupt as much, as little surface as we can. If we had all the room in the world, we could build a nice 8-foot berm around our locations, and that really attenuates a lot of noise. And then you can put hay bales on top of that. Hay bales are another issue. We may use frac tanks in some in some instances. There's a list of things that you can do, but I'm going to reiterate, proximity is #1. If we can get away, we'll get away from where you're at. hours of operation. These are 24/7 operations, but we may leave certain things that we wouldn't do in the past to daylight instead of doing it at night. One of the other areas that we've made a lot of movement is in sand. Unfortunately, we still have to bring sand to locations with trucks. We're trying to work on that too, how we can get those trucks off the road. But we've gone to different operators have different box systems that we use. And by using that, we've gotten rid of the pneumatics of blowing all that sand into these things. That's one of the most obnoxious noises you'll ever hear. It turns out it's not a real big sound source, but it's a shrill that when you hear it, it just drives you nuts, even if you're in the industry. So we've eliminated that and got that source off there. One of the other things we really haven't talked about is just truck traffic in general, getting trucks off the road, water systems. Instead of hauling all this, the water by trucks like it was done, not that long ago, we have pretty extensive water delivery systems. We have water takeaway systems now for produced water rather than those trucks. So getting them trucks off the road, when we do have trucks show up, have them come up during the day, not during school out, bus hours and things like that. Work with a lot of different, the communities with a lot of traffic scheduling and such. But that's another mitigation that we do, is just getting the trucks off the road and such.
I'd second a lot of what Mike said. You didn't leave me much. The location's huge. That selection up front, as far away as you can, maximizing technology with the 1 mile reach, and those sorts of things like we mentioned earlier. I would also say pad size matters. So if we're going to go drill 16 to 20 wells in a 1 mile section, oftentimes in an urban setting, just because of lack of land availability, we're forced to put one large pad there. Actually, that's not preferable. We would rather have 3 pads and put a rig on each one and drill 5 wells on each pad and get in and get out quickly. That duration matters a lot in terms of exposure. That may be one of the better mitigation techniques we have, is to minimize duration. And it's good for us and good for you, as we talked about earlier. And then we not only during the drilling and fracking stages where we can pipe water instead of truck it, as Mike said, but also we'll get into maybe later the benefits of pipelines where the scale supports it in really the 29 other remaining years of a well's life. The drilling and fracking, on any given pad is probably about a year, year and a half, depending on pad size. It's 29 years of producing life where pipelines really matter to transport oil, gas, and water, all three, to maybe a central location or at least the third-party marketing company, where you can really take, honestly, tens of millions of truck miles off the road. And that's a big deal. And you can also take tanks out, and we'll talk about air mitigation later too, and tanks are a big deal. I've always said I'm a tanktivist where you can. I don't like to put tanks out. I'd rather have pipelines and minimize our tank coverage. So we'll get into we're kind of broaching into some other subjects there, but location, efficiency, pad size, pipelines, and then all the different mitigations that Mike talked about quite extensively.
So just to recap, before I know we're going to take a break here in just a little bit, we will come back to roads and containerized sand and some of those topics. Just did have some pictures for you guys to show of what are things that I'm sure everyone in here has seen a sound wall, but just kind of understanding what it is when you go to a location and you see certain things. So this is an example of just hay bales and a berm. And like Mike said, sometimes you don't always have the luxury of having materials there for a berm. So then you are faced with the decisions of, do you put up a wall, do you truck in and make a berm? And by doing that, not only can that be extremely expensive, but then you are substantially increasing your truck traffic on the road. So sometimes a berm isn't always an option, but if it is, sheer mass between the operation and a stakeholder is always an advantageous way to go. This is an example of an area where we did have the opportunity to have a bit of a berm, and you can see here that some of these berms can get large. That almost just doubles the height of the hay bales there. So if you have an area where you're like, oh, you have a wall, but then you have a location where you could have a berm and bales, you still could be looking at 2 extremely effective mitigation techniques there, and it could be that you had a wall because you didn't have the luxury of the berm, when you do see some of the largest benefits from again, that sheer mass between you and a stakeholder. This is a picture of just inside the pad where you can see where we'll really work on trying to building that up, and we want to be able to maximize the height for those berms. And then obviously always trying to stack bales on top. Sometimes we do get questions of, well, why can't you put another row of bales there? And really that's a safety issue, is that we only like to go up so high that we can support and make sure that it is safe, just like every other area of our operations. So it's not that we wouldn't want to stack bales up higher and provide that additional visual barrier, but we're never going to put anything out that's not going to be safe. So that's something that I know that is a limitation that sometimes we get questions of, well, why don't you just go add another row of bales? And it strictly is not that we don't want to do it, it's just a safety concern. You also will see sometimes that locations will have combinations of hay bales and sound walls. And that's, again, just that site-by-site evaluation. If you have the luxury of having one side of your pad that does have a berm, you might not need to put a wall there, and you can stack some hay bales on top of that berm. But then if the pad dips at other places, then you might need to utilize a different material. This is just a picture of kind of the install of a sound wall project on the inside. This is an industrial operation where steel beams are either pile driven into the ground or drilled into the ground, and then you mount different types of acoustic materials and panels and stack those to get these walls. And one thing to always consider with these is just duration, that if we're coming in and we are, say it's a 4-well pad and it's smaller, going in and then spending 5 to 10 days to install a sound wall can be much more intrusive or irritating to nearby stakeholders as opposed to just coming in and drilling those wells in a few days. So we have had situations where people have, reached out and said, I thought this was a 4-well pad, and they're like, you spent 2 weeks putting up that sound wall. And that is something that always you take into consideration, is how long are we going to be there? That is the mitigation that we're implementing disturbing them more than if we were to potentially use a different option. You'll also see breaks in sound walls, and sometimes you'll see where it's either you'll have 3 sides wrapped, and that could be just if there aren't any homes on different sides of the pad. Sometimes we won't put walls in those areas, and that also is really, again, just if it's not necessary, we don't want to have extra equipment out there and increase any additional safety considerations on a location. But you will see, sometimes we get calls and they're like, there's a break right where it faces my house, and that's also because of safety, is that you'll always have areas where if there ever was a situation on location, we can't have all of our employees entrapped in a steel structure that doesn't allow them, those areas for safe access. So here's an example of just a partial wrap, and then here's just a little drone footage, and you can see right there in the center, that's just an example of where you'll have to have a break in the wall to be able to allow for that access in and out for safety. And then the last thing that I'll talk about with these is when we were talking about, like Mike said, source panels. So you have the perimeter walls that can go around location, but then a lot of times there is stuff inside those walls that people don't see, and those panels actually that are, again, close to the source can be even more effective than the larger exterior walls. So that's why those analysis up front are so critical, and it's so critical that they're site by site, because the equipment will be different and you'll have different noise and light offenders on all of those equipment. So by modeling it and knowing the specifics of that location, you then can look and say, okay, is it a perimeter wall? Is it a berm? Or if it is just 1 or 2 small things on a particular rig, you can utilize these portable source panels that come in all different shapes and sizes and have all sorts of different types of acoustic dampening materials that can be attached to them. And those will often be utilized inside, closer to the operation, that a lot of people don't see. Sometimes they can be on steel frames. Other times they can be on K-rail systems or cement. But there could be a time where you see something like this, where you just see a few panels around a certain portion of that, of a drilling rig, and you're like, well, why didn't we get the whole wall? And they're not really walls. They're actually panels that we're putting close. But again, that modeling is so critical to see, a lot of times that will be more effective than the actual perimeter wall. Do you guys have anything on?
No, I think you covered it well.
Okay. All right, so with that, do we have any questions about bales, berms, walls, panels before we go on a break?
How many people in Rifle are wanting to be transferred to Broomfield and Boulder? Anybody?
Yeah.
Hold on one second.
What was your decibel reduction from rapid trucks? What was your decibel reduction on when you wrapped the pump trucks?
Sure. So we like to look at it like this. We actually have seen 3 times reduction. Talking about decibels, it gets really confusing with a lot of people, and off the top of my head, I'm not quite sure what the numbers are, but it's basically a 3x reduction in what the noise is. Anecdotally, using my ears, going off to the edge of location where a neighborhood was, when we first brought this out, I figured I got to see this for myself. We were fracking about 80 barrels a minute, and about 300 to 500 feet away in this neighborhood, I'm guessing that's about where I was, got out of my truck, turned the truck off, and the first thing I could hear was some guy mowing his lawn. So I had to wait for him to stop mowing his lawn, and then I'm sitting there just with my eyes closed. What do I hear now? And I heard a plane from DIA. And that finally got out of the distance, and then the next thing I could hear was the wind blowing through corn stalks. That was the next thing I could hear. So it's a dramatic reduction for people in the neighborhoods. It's a dramatic reduction on location. The entire location now is OSHA hearing safe. You'll still see guys on location wearing the earphones, because that's how we communicate with each other. There's radios in there. But the entire location is now hearing safe. You can now stand in between 2 of these pump trucks and have a conversation. For any of you that have been on a frac location before, standing in between 2 pump trucks, even yelling at each other, you probably won't hear each other. So it's a dramatic change. You're hearing all sorts of weird things now, like we can hear the fluid flowing through the pipes on location. Very bizarre. Exciting, but things that didn't know you could do. Does that answer your question well enough? Yeah. Okay.
Any other questions?
Heidi, can you explain a little more about the modeling you talked about doing with the party video?
Yeah. You guys want me to take this?
Sure.
So with the modeling, a lot of times operators will utilize third-party acoustic vendors. Some of them specialize in oil and gas or just industrial operations in general. In those models, basically, there's a standard programs that pretty much equipment and technologies can be tested, where you get kind of your manufacturer ratings for sound and all that. So those are all built into software programs. Then you'll take the specifics of that location. So you'll take the location of the wells, the topography in the area, even the time of year and the climate can impact a model substantially. And then they basically run what would be a predicted analysis of that equipment, and then also look at the surrounding homes, and we'll look at what's those potential impacts and how does that work. And there's so many things and factors that go into them, but really when you get a model, it's not this is exactly how it's going to be. We always like to be clear about that. These are models, they're predicted impacts. However, we're spending a lot of time with them and we're learning them more and more, and they are extremely accurate. And basically through these different types of software programs, you'll put in what type of rig it is going to be, what's the orientation, what particular how much will you be pumping, and you put all of those factors into there, and then you can kind of get an idea, at least a predicted idea of what those impacts are. And the critical thing is that when you evaluate a location, you want to evaluate it from a data perspective, but it is so critical to evaluate it from a social perspective. What community are you in? How close are you to people? What are their concerns? Noise is always a hot topic button. People, you think that that's what everyone's concerned about, and I think at Anadarko now we've serviced over, I think, 1,000 to 1,300 people, and noise isn't the only thing that they're concerned about. So the model's just one piece to kind of a evaluation, but it needs to be a technical and a social evaluation. But the model is such a critical piece of data for that, and I know that we utilize it quite a bit. And then you do them for a few times, and then you can really get an idea. Like Ben was saying, when you live in operation and you're there, you remember what those impacts are, and then you also remember the benefits that you've got from specific types of mitigation. So we'll get a model that will say, here's what it's going to be, and then they'll say, you know, we recommend this, and that might be the product that that particular vendor sells, and they would like to rent to us for that duration of wells. But we could have worked with a different vendor that, you know, we had similar impacts, predicted impacts, and we found that panels or mufflers or baffles were actually more effective for that type of data. So it's really kind of the first stab at looking and evaluating, you know, what are the potential impacts here, and it's kind of the, at least the baseline, and then you go from there.
It's a lot more I would have said.
A lot more than I could have said.
All right, so with that, any other questions? Clearly I could talk panels all day, so you just let me know.
Heidi, I have another question, but I could wait till after the break or two if everybody, I don't know if there's time, but I'd like to talk or hear from you. So my name's Tammy McMullen. I run the Oil and Gas Health Information and Response Program at CDPHE, which is a relatively new program, and we receive a lot of calls from citizens primarily around health symptoms and reporting of that. But one thing that we get like all the time now is really around drilling and odors. It's like, and I, you know, talk with operators to try to understand, and they say, yeah, you know, we know this is like the new noise.
Mm-hmm.
So I'm wondering if you were going to touch upon that in the next session, or
We are, yeah.
I mean, this has been really, I wanted to say this has been great from my perspective to learn, so we can communicate these things to the public too. But so I'd like to hear a little bit more about that sometime today.
Yeah, we will be, once we come back from session, we will talk about odor in roads.
Okay, great.
Can you just repeat the questions?
Oh, sorry. Yes, she didn't have a microphone. She was asking, so you're with the CDPHE, and you guys have a new kind of response, health response line of sort. And basically she was asking if they're receiving lots of calls and concerns about odor, particularly related to drilling. So she was wondering if we were going to then be going into odor, which we will be. So Kirby, if you want, we can go ahead and take the break now. And then